What we can see here, though, is that there's a layer of complexity in these execution contexts. In these execution contexts, so many hard consonants. In these execution contexts, there's a level of complexity here that we can visually see. It was Skylar who said, I finished running multiply by 2, I return 8 out into the global execution context and the global variable output. Now, Skylar can see that because he can see multiply by 2 is to the right-hand side of the output constant. He can visually see when I finish inside multiply by 2's execution context, return to the execution context in which I was previously in. But JavaScript doesn't have that sort of visual sense of how these boxes are working, where it has to track which execution context I'm in at any one time. Am I inside multiply by 2, the call to the multiply by 2 function? Am I inside the call to this next call to the multiply by 2 function? Am I inside the global sort of call, the global execution context? If I were to run another function inside of multiply by 2, where would that be? It has to keep track of where it is and where to go back to when it finishes where it is. So if I'm inside the call to multiply by 2, when I'm finished, because I called multiply by 2 in global, I want to be able to know to go back to global. And JavaScript has a special sort of data store to track that journey, where it is, where it was, and therefore where it's going to go back to. And that structure, anyone know what it's known as? Z?
Stack?
It's a stack, call stack. It's a stack of calls to functions. When we call a function, we create an execution context. So it's a stack of our calls to functions. We call it the call stack. And here it is, the call stack. Perfect. And it is a great way of representing. It's a great way of representing our functions being called inside of each other. I start off in global. So a stack is something from our world of programming, from computer science, and it's just like an array. An array says, I want to store data as a list where I care about the order of the data, and I also want to be able to go grab a piece of data at position 7, at position 2. A stack is perfect for tracking our execution context, because stacks, I only care about adding something to the top of it, like a stack of plates, adding something to the top of it. I can't take a random plate out. I only care about adding something to the top of it, and then when removing that plate, the next plate down is still there. That's all I care about. Same thing here. I only care about adding something, multiply by 2, inside a global, and then when I finish running multiply by 2, knowing to go back out, getting rid of multiply by 2 and going back out to global. It's a really great way of representing our calls to functions. And the first one we add, therefore, to our stack of calls is our global execution context. And we never leave that one. As long as our application is running, it's always there on the bottom. When I start executing multiply by 2, I add it on top. Multiply by 2 invoked with 4. That is for when I am inside. So while I was inside of this multiply by 2 function, so it was on top of my call stack. And when I step out of it, what do we think happens to my multiply by 2 function on the call stack, Philip?
It pops off.
Aha, I remove the call. And the posh name for removing from the call stack is to pop it off. To pop the call to multiply by 2 off. The posh name for adding it is to push it on, pop it off. All right. And if I were to run multiply by 2 again with 10, that would be added on the call stack again. And if I then call another function inside of here, that would be then added one layer above to my call stack. All right, so my call stack is my final piece of the core fundamentals of how our JavaScript code executes. When you execute a function, you create a new execution context which all that is, all an execution context is, nothing sounds so profound, but all it is our thread of execution, meaning we take the code of multiply by 2 and we start going through it line by line by line, storing stuff in memory as we go. And, as I say, a local memory, by the way, sometimes known as a variable environment, in which everything inside that function, anything gets defined, is stored inside that function's local memory. All right. And that execution context, we keep track of those with our call stack. Our call to the function is tracked, our call to the function is tracked on our stack of calls. And this, people, is all of our fundamental building blocks of JavaScript's execution. This is it. We've seen it all. Okay. As I say, we keep track of our calls in a call stack. Folk, we now have the underlying principles. We can see straight away, I know that calling multiply by 2 with the input of 4 returns to output 8. I didn't need to look at it for 1 second. But when I have these foundational pieces built out with clarity and completeness, all the hard parts follow more naturally. So this was our hard parts preamble. Now we move on to hard parts part 1 for real, callbacks and higher order functions.